In this fifth video on factorization, we're going to have a look at factorizing trinomials. And the trinomials we're going to start off with are fairly simple because, as you'll notice, none of the x squared terms have a coefficient greater than 1. Remember, if there's no number in front of a variable, it's an imaginary 1. So what I really want to convey today is how to work out how to generate the two brackets that factorizing a trinomial will do, and how to work out the signs inside the brackets. So first of all, as I've said, we are going to generate two brackets with this as we factorize it. And in the two brackets, each bracket's going to contain a binomial. So the first thing we need to do is to have a look at the constant term, which is the term that is standing without a variable. And we need to look for a factor pair to get to 5. So in other words, what number times what other number can give me 5? And because it's a prime number, there's only one option, and that's 1 times 5. So once you've found your factor pair, then you need to look at those two numbers and see if those two numbers can give you the middle number through either addition or subtraction. And we can see that 1 plus 5 would give us 6. And as we learn the rules, we'll realize that because this is a plus sign, we are needing to have an addition situation over here. So as we look at what's going to go into each bracket, x squared is going to be broken up into x times x. And then the 5 is going to be broken up into 1 times 5. And then we need to look at the signs. So if the second sign, you need to look at the second sign first. If the second sign is positive, then it means that the signs in the brackets are the same. In other words, in these two brackets that we're generating, both the signs are going to be the same. Once you've looked at that second sign to ascertain that, you're then going to look at the first sign, and we'll see that they're going to be the same, and they're both going to be that sign, which means that the signs in my brackets are the same and they're both positive. So now I can just put in my signs. And if you go to a video on multiplying brackets out, which will be going onto the channel quite soon, you'll see that by using the FOIL method of multiplying firsts, outers, inners, and lasts, we will get back to that. So when we're factorizing a trinomial, we're creating brackets, and when we're expanding the product or multiplying two brackets out, then we get back to that form where there are no brackets. So let's have a look at the next one. Our constant in this case is 12. So we've got different options here because it isn't a prime number. So let's say, for instance, you think first of all of 6 times 2. Can 6 and 2 give me 7? No, well, they can't give me 7 through addition or subtraction. So that's definitely not going to work. I leave them there. I don't erase them or anything because I want to always be able to look back and see which combinations I've used. As the numbers get bigger, there might be more combination options. So another option for 12 is 3 times 4. Can 3 and 4 give me 7? Yes, they can. So now I know that my two brackets are going to contain x squared is going to be split into x times x, and of course x times x would take me back to x squared. And I've worked out that I want to factorize my 12 as 3 times 4. Right, then again I go back to my signs, and I always look at the second sign first. So again, because the second sign is positive, it's telling me that the signs in the brackets are the same. And then once I've looked at the second sign, I then go back and I look at the first sign, and that first sign is telling me that they're going to be the same, and they're both going to be negative. So then I simply put in negative, negative. Right, looking at this example now, let's set up our two brackets. And let's look at factors of 12. Well, we had a 12 over here. We've got a 12 again. Let's look at 3 times 4 this time. Can 3 and 4 give me 4? No, they definitely can't. So in this situation, the 3 and the 4 don't work. So let's go back to the 6 and the 2. Can 6 and 2 give me 4? Yes, they can, but only if I subtract 6 minus 2. So that is fine actually, because the second sign, if the second sign is negative, you are going to end up with a subtraction situation over there. So let's put in little notes for the second sign. Remember, always read the second sign first. So this tells me that the signs in the brackets are different. And obviously there's only two differences. It's either positive or negative. And then I go back to the first sign, and this one is telling me that the larger number is this sign. In other words, the larger number in this case has to be positive. So let's first of all set up the brackets. X squared is going to be x times x. We decided that the 12 is going to be 6 times 2. And then going back to my rule, that is telling me that the signs in the brackets are different, and the biggest one is positive. So remember, the sign always comes before the number. So this 6 will get the positive, because that positive will then belong to the 6. And if that one's a positive and they have to be different, obviously that one has to be a negative. Looking at our last example, let's look at our constant number again, 18. So I could use 6 times 3. So let's test that. 6 and 3, can they give me 7? Definitely not. So let's try 2 and 9. Can 2 and 9 give me 7? Yes, through subtraction. If I say 9 minus 2, I'm going to get 7. And this again is telling me that it's going to be a subtraction situation, and it's also telling me that the signs in the brackets are different. And once I've read that second sign, seeing that they're going to be different, I go and look at the first sign, and that first sign in this case is telling me that the larger number is, in this case, negative. So setting up my brackets, x times x is x squared. We've decided we're going to use 2 times 9 for the 18. And now I'll check again, the signs in the brackets are different, and the larger one is negative. So looking at my two numbers, that's the larger one, so the negative goes in front of it, and the other bracket gets the other sign, which in this case is positive.